Remember last time we showed you how to graph individual inequality equations, and then we looked at least setting up those giant word problems, those applications. They were quite complicated and quite hopefully practical for you, you'll see. But all we did was set them up. Well,
there's something I have to ask you.
How do we solve those monster problems? How do we actually get the answer? Well, let me give you an example. We'll take a simple function, x times y. That'll be our objective function. We want to maximize it, we'll say. Okay? Under the following constraints. Okay, remember we had a list of constraints and we only had one objective function always.
It's always best to start at the beginning.
We're going to start by looking at the constraints, actually. We're going to graph all the constraints, which are all inequalities, on the same graph and see where they intersect. That's our goal. We'll start with the first one. Let's do this one. Well, we have two methods, remember. Let's do this one by solving for y, because it looks like it's easy to solve for y. I'll subtract x from both sides, and I'll get y is less than or equal to 6 minus x. And I'll pretend kind of that y is equal to 6 minus x, and I'll get 3 points. If I put in a 0, let's see, 6 minus 0 is 6. There's that point. If I put in a 1, 6 minus 1 is 5. And if I put in a 2, 6 minus 2 is 4. And there's my first line. And y is less, so I shade below. Okay, that's the first equation. Now let's stay on the same graph, and we'll do the second equation. This one, it's a little more difficult to solve for y. It's not that hard. But I'm going to review the intercept method for this one, okay? Because it kind of reeks of the intercept method. Remember that? We put a 0 in for x and find a point, and put a 0 in for y and find a point. Let's see. If I put in a 0 in for x, y is going to have to be 4. 2 times 4 is 8. And I'll graph that point. If I put a 0 in for y, x is going to have to be 8. And there it is. Let's graph that point. 8, 0. Okay, now let's see. It's going to be a solid line. How do I decide whether to shade above or below? Remember I used 0, 0 as a test point. Now with 0, 0, 0 in for x, 0 in for y, I get 0 plus 2 times 0 is 0, and 0 is less than or equal to 8. So that one does work.
You are correct, sir.
So since 0, 0 works, it must be on the correct side for me to shade. So I will shade in that direction. What I'm doing here is just shading with arrows so you can see which side. Okay, of that one. Now the next one, y is greater than or equal to 0. Oh, that's an easy one. I'm going to use, remember these points? That's the one where y always equals 0. Always equals 0. There's 1 point. Always equals 0. There's another one. Just always put in 0. Remember this one? For y now. Okay, we'll shade that. Let's see, it's going to be a solid line, and since y is greater, and it is solid for y, I know to shade above. Okay. Oh, looks like a torture chamber there. Okay, last one. X is greater than or equal to 0. Now this was a weird one we had. We reviewed it last time. You thought you'd never see it again. This one, we can let y be anything, but x has to be 0. So we'll have 3 points where x is 0. You can put in any number. Of course, for y, so I put in 0, 1, and 2. 0, 0, 0, 1, and 0, 2. I'm feeling good because they line up. This also is going to be a solid line. And where does x get bigger? I don't get above or below here. I have to be right or left. Remember, x gets bigger to the right. So that's all of your constraints graphed. Our job now is to decide where do they intersect.
Now I want answers. I shall have answers.
The region where they all meet, where all the constraint meets, we call the feasible region, because it's feasible because it meets all the constraints. So you're going to have to look at it, and that's going to be the region where they all meet.
Prepare to be astonished.
Let's zoom in a little bit and look at the feasible region. Now up to this point, we really haven't done anything new. We just did a lot of equations on the same graph. Here's what we're learning new today. The fundamental theorem of linear programming. Sounds like a lot, doesn't it? The fundamental theorem. What's fundamental about these? Well, in a programming problem like this, if the region that you're looking at here is non-empty, because we have to have a region, and convex, doesn't have any dents in it, okay, you won't get that. The maximum or minimum that we're looking for, here's the big kicker, will always occur at the corners. Now, this one has 4 corners. So we're going to have to check out all 4 and see which one is the maximum. But 4 isn't too bad. I can deal with that, okay? And I get a very useful answer in this case, okay? Remember, our maximum objective function is x times y. I picked an easy one this time. Okay? So let's look at the corner points. The first one, 0, 0. That's going to be a common one, by the way. Not always, but it's a common one. And what would x times y be in that case? Okay, well, there's my first winner, if you would. See if I can beat him. Okay, now the next one, the corner is at, as you can see, at the point 0, 4. And what would x times y be there? 0 times 4. And it would still be 0. And then another corner is 6, 0. Of course, 6 times 0 is 0. But we do have a 4th corner point. And that's the point 4. Look, over 4 and up 2. And what is that? 8. And it's knowing from the fundamental theorem of linear programming that our maximum has got to be one of these 4 points. It's going to have to be 4, 2, isn't it? Because he's the winner amongst those 4. And that's all you have to do. You graph the constraints, look at the corners, and kind of plug them into whatever your objective function is.
Okay, see now, what I just heard? Blah, 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 blah. Okay,
we'll do it. This is complicated, isn't it? Let's do another one. This time, we're going to maximize a function 2x plus y, okay? Under these constraints, okay? Now that could be, I don't know what p is. That could be a function of principal or who knows what. Profit, hopefully. That's what we'd want to maximize, okay? Okay, well, how do we begin? We're going to begin by graphing all the constraints. And get used to these 2 constraints being there almost all the time. You got to get good at y being basically a positive number and x being a positive number. They're not always there, y being bigger than 0 and x being bigger than 0, but they're very often they are there.
It's always been to start at the beginning.
So let's start by graphing these constraints.
And now, ladies and gentlemen, let's get ready to rumble!
Well, let's see. This first one, how should I do it? It's pretty easy to solve for y in this one, so let's do it that way. You don't have to do it that way, but let's do it this way just for review. Subtract 2x from both sides. And okay, let's put in, I don't have a fraction here, so I can put in my 3 easiest points, 0, 1, and 2. Now if I put in a 0, 12 minus 2 times 0, I'm going to get 12. So the point 0, 12. Okay. If I put in a 1, 12 minus 2 times 1 is 10. So I get the point 1, 10. And if I put in a 2, 12 minus 2 times 2 is 12 minus 4 is 8. And hopefully 2, 8. Ah, they line up. Okay. We're going to have to draw the line and decide whether to shade above or below. Since it's less than, I say to the left, but it really is down, isn't it? Okay? Okay, that's one of them. Now the second one. I'm trying to rotate between graphing methods here. I'm going to use the intercept method just so you're comfortable with both. Okay? And this one, it would be more difficult likely to solve for y in this one. It wouldn't be impossible, but you'd get a fraction. So I'm going to stay away from that and use the intercept method. Let's see, the intercept method, remember, is to put a 0 in for x and figure out what y is. That'll give me the y-intercept. And put a 0 in for y and figure out what x is, and that'll give me the x-intercept. Good old 0. So easy to work with. If I put a 0 in for x, the y's got to be 4. 5 times 4 is the 20. There's the point 0, 4. If I put a 0 in for y, let's see, 2 times 10 is 20. So I get the point 10, 0. Okay, let's draw the line. And I have to, of course, you can't use the sign there. You're going to have to use the 0, 0 point as a test point. Now, if I put in 0 for both of them, 2 times 0 plus 5 times 0, that's 0. And that is less than 20. So I guess 0, 0 works. So he's on the correct side.
Excellent.
So I'll use that. So I have both of those graphed. 2 more to go. And I'm real good at this one. Y is greater than or equal to 0. Let's see. Do that real quick. I can put that one in. Remember, greater than. I'm going to go up. And then the last one. X is greater than or equal to 0. I told you, get to know these ones. Well, I'm going to draw the line for x being 0. And where does x get bigger? He is bigger. Go to the right. Okay, now we got to look for a feasible region here, don't we?
Just as I suspected.
The feasible region where they all meet. Can you see where all the arrows? It's going to be some figure.
Well, duh.
There it is. Okay, you got it. Okay, let's zoom in on this feasible region. Now, it's not always, what is this anyway? It's not always a rhombus or whatever. Okay, I guess it's not always a four-sided figure. It could be a triangle sometimes. Could be a pentagon sometimes, okay? This one just happens to have 4 points again, okay? Now remember what we do. Using the fundamental theorem, we're going to check out the corners. The first corner is easy. We check them out and see what does the function p give me for that if I put a 0 in for x and a 0 for y. Then I check this one out, 0, 4. And I check this one out, 6, 0. Then I check this one out, 5, 2. And we'll see which one. It's not always, you never know which one it is. Okay? Let's try it. Put them in. If I put it this function in, 2 times 0 plus 0, I get 0. Let's say P is profit. Profit would be 0 at that place. Remember, I'm trying to maximize. In this position, if I put a 0 in for x and a 4 in for y, profit will be 4, won't it? 2 times 0 plus 4. If I use this position, 2 times 6 plus 0, profit will be 12. And if I use this position, 2 times 5 plus 2, ooh, I got a weird thing here. I have 2 12s. So I have 2 winners. It can happen. But the point is that you've maximized the objective. You've maximized the profit. And this is great news. if this was in fact a profit, you have two methods of getting it, don't you? You could tell your customer, well, depending on what X and Y are, you have two methods of maximizing profit. Now I've been throwing these corner points at you because we could just see them on my graph. You may have to find them yourself because they don't come out all even like this all the time. Consider, especially this one. Consider that that point is the intersection of two lines. This one, the gray one, and this one, the red one. How did we find, if you couldn't see it, okay, if you wanted to find the exact intersection of those two lines, you remember how to find it algebraically? That's what we did on the first day, is find out. And we had really a couple methods for that.
I'm back, baby!
Remember the elimination method. We called it the addition method. Okay, and what we did was we multiplied one of the equations by some number so that one of the letters would cross out. For instance, in this case,
You have chosen wisely.
I would have chosen -1 to cancel out the x's. Let me multiply that equation by -1. And I'd get a negative. Of course, I got to do everybody by -1. I get -2x, -5y, and -20. Then I look at these two, you see, and add them together.
Hasta la vista, baby.
The x's cancel out, and I can solve for y. Well, let's see. I'm going to have to divide by -4 on both sides. And as we told you before, y would be 2. But what if we didn't know that? We'd have found y is 2. We still need to find the x, because this is a point. Two numbers, a pair, make up a point. Remember how to do that? Well, you take what y is equal to, put it into the other equation, and then you only have one letter, you have x. Solve for x. Let's see, subtract 2. And in this case, divide by 2. And as we knew before, x would be 5. So there was one method we gave you, just in case you're having trouble finding these corner points. Now there was another method we gave you to find the intersection of two lines. Do you remember what it was?
Excuse me, Professor Brainiac.
We called it the substitution method. Many of you like this even better than the elimination or addition method. What we did in the substitution method, and this one reeks of it, was to pick the one letter that's easy to solve for. And in this case, I'm looking right at that blue y. He's almost by himself now. And I solve for it. In other words, get him alone. Then, remember what we did with that? We took the expression that y was equal to and put it in to the other equation there instead of y. Okay? And then what we had was an equation with all x's, didn't we? And now we can solve that equation for x by combining like terms, the 2 and the -10, and then getting x alone. Let's see, I'd subtract 60 from both sides and maybe divide by -8, and x would be 5. Oh, I knew that already. But now, how do we finish this off? Because once again, remember, we're looking for a point. We're looking for a pair. Basically, we need to find y. What do we do? Well, we have new information now. We have that x is 5. I turn to the other equation and put in 5 instead of the x, because that's what x is at this point. And now I can just solve it. Y is 12 minus 2 times 5, or as we knew already, y is 2. So a substitution method is another method that you can use to find points, these points of intersection, which are going to be critical in solving these problems. Now there was one other method that you should know to find the intersection of two lines. And that is
Now are you my secret weapon?
using your calculator. We'll call it the calculator method. If I have the two equations, which I can't use them on a calculator till I solve them for y. Let's solve them both for y. So I get y is 12 minus 2x. And this one, it's going to be ugly to solve for y, but remember my calculator can handle ugly problems. And then divide by 5. And I'll get y equals 4 minus 2/5 x. Okay. Now, if I take my calculator, turn it on, I hit y equals, clear out anything that's there, and type the first equation, 12 minus 2x. Okay, don't graph yet, because we still have to put the other one in. Cursor down to the y2, and put in the second one. y2 equals 4 minus 2x divided by 5. Okay, now hit second trace. That's going to help you to find, it's going to bring up, what do you want to trace? And what a second trace is calc. And hit 5 for intersect, and it'll find the intersection of those two lines. You'll have to hit enter a couple times, but it will find it. How cool is that? Let me try it. Let's see. Move this over. So I'll hit, I already have it on. I'll hit y equals 12 minus 2x. Now I'll cursor down. There's the cursor. Okay. And what's that other one, just in case I forgot? 4 minus 2x divided by 5. Okay, now I could graph this. In fact, let's do that. And it draws the picture. But I want to know exactly what point that is right there. So what I can do is hit, what is the calc button? Well, the only way to get the calc button, of course, since it's orange, is to hit second trace. Okay, and I know what I want. I want intersect. So I can either cursor down to it, which I'll do, or you could just hit 5. I'm going to cursor down to it and hit enter. Okay, and it asks me to pick which curve, and I'll let it pick it by hitting enter. Okay, and then pick the second curve. I'll hit enter again, and I'll hit enter again, and son of a gun, it'll find, how cool is that? It'll find the intersection. Tells me it right here. Intersection is 5, 2. How cool is that? So you can use your calculator. Of course, it could have been 5.295 and 2.146, and the calculator still could have handled it. So that's a great tool. Okay. Okay, I'm going to clear out of their calculator there and hit clear again to get back, just so I can leave you in the same spot. And let's actually try and do
As always, should you be
one of these big old word
the
problems.
Secretary will disavow any knowledge of your actions.
We're going to finish it. We're going to bring it all the way to the end this time. Okay? Let's see. This is an investment club we're talking about. Okay, the Neighborhood Investment Club has at most $30,000 to invest, $30,000 to invest in stocks and bonds. Each of these two things, stocks or bonds, must be purchased in $1,000 increments. Now, the bonds typically yield 7% profit. They're very safe. While stocks yield more, they yield 12%, but they're a little somewhat risky. Okay? You want a little bit of both. You want to make a lot of money, but you want to have, a reasonable amount of risk. So the club has agreed that they should always keep at least twice as much in bonds as in stock, so that they're not going to lose a lot all of a sudden, perhaps. They want some stock to make some money, but they don't want too much risk. How much of each type of investment should they buy to maximize their return based on these constraints? They want to know how much. And then they want to know, what is the maximum? Okay, what will it yield if they use these maximum numbers? So we really have a couple questions to this. Well, as always, let's define what our variables are. let X be the number of bonds in $1,000 increments, and Y be the number of stock shares in $1,000 increments. Okay? Once we've done that, we need to come up with an objective function. Now in this case, we're going to be trying to maximize stuff. So what are we maximizing? I think we're maximizing our return, our investment return. And that's going to be 7% of the stocks plus 12%, I'm sorry, 7% of the bonds plus 12% of the stocks. So my return function is 7% times bonds plus 12% times shares of stock. Okay? Now, that's our objective function. Remember that we always have some constraints. So the first constraint is the most we have is $30,000. Okay? So X plus Y has to be less than or equal to, remember it says at most $30,000. And since I'm working in $1,000 increments, I don't want all those zeros. I know I'm going to be working in thousands. So I'm just going to use 30. I'll know what I'm talking about. I know what unit I'm talking about. Okay? So the amount of the two added up has got to be less than or equal to 30,000. Now they also have agreed that they have to keep at least twice as much in bonds as in stock. Okay? So twice the stock has got to be smaller than or equal to the bonds. Got the idea? Or you could read it backwards and say the bonds have to be more than twice the stock. That way they're not getting too risky with their investments. Okay, any other constraints that they haven't really said? Now there's our usuals. We're not going to invest negative money. Okay? We're not going to buy negative bonds, and we're not going to buy negative stock. So both of those numbers have to be greater than or 0. And that will help us close out our little shape, whatever it is.
It's always best to start at the beginning.
Okay, well let's once again start by graphing the constraints. We'll graph this one. X plus Y is less than or equal to 30. I'm going to try the intercept method on that. Put a 0 in for X, and I get 30Y. Put a 0 in for Y, and I get 30 for X. And there's that line. And it has to be less than that. But since I use the intercept method, I'm going to have to use my 0, 0 test point. Okay? And 0 plus 0, well, it is true, so I do want to shade that portion of the graph. Okay, so there's that one. The next one, I'm going to use the solve for y method. Okay, I'll divide by 2, and I'm going to put in some points for x. Notice that I'm not putting in 0, 1, and 2. I could, but I'm going to make life easier for myself by putting in multiples of the denominator, 2, so that I get whole numbers. If I put in a 0, I get out a 0. 0 divided by 2. If I put in a 2, they nicely cancel, and 2 over 2 is 1. So the point 2, 1. If I put in a 4, 4 divided by 2 is 2. So I have the point 4, 2, and I can draw that line, and y is less. Where does y get less? Down. Okay? This one isn't forming a rectangle, is it? Let's see. I got to do my y is greater than or equal to 0. I know where that one is. And x is greater than or equal to 0. I know where that one is. Now, what portion of this graph is green and red and gray and blue? Look at it. If you continued your lines on, you'd see. There it is. Remember what we call that, the feasible region. And remember what the fundamental theorem tells us, that our maximums or minimums are only going to occur at the corners. So this time, this is sweet. All we got to do is check the 3 corners and see what return we would get at those positions.
Don't leave me hanging.
Let's finish it off. The first one's easy, the 0, 0 point. The other one is 30, 0. I wonder what point that is. That might be tough to see. It's going to be the intersection of this line and this line. Now you're going to have to find that intersection. Okay?
Allow me to demonstrate.
How should I'm going to use substitution this time because I have the letters practically alone. I'm going to use substitution to find that point of intersection so that I can in fact test it. Okay? Well, x is equal to 2y. So I've already got one of them solved, so instead of x, I'm going to put in 2y. And I'll have an equation with just y's. Not that hard either. 3y is 30. Dividing by 3, in that spot, y must be 10. Now I still need to know x. Well, let's put 10 in for y like we know and find out in the other equation what x is. X is 20.
Go ahead. Make my day.
Okay, all we have to do is figure out which point is the winner. At this point, the return
Make it so.
would be putting in a 0. Wouldn't be very much, would it? Going to be 0. I don't think he's going to win. At this point,
Make it so.
putting in a 20 for x and 10 for y, it looks like the return's going to be 2.6 thousand or 2.6. Actually, it's going to be 2.6, but we remember we're counting in thousands. Okay? And at this point, 30 and 0,
Make it so.
it's going to be 2.1. Well, we have a clear winner at the point 2010. But
The important thing is, isn't your final answer?
we have to answer the question. The question asked, first of all, how many bonds do I buy? How many stocks do I buy? Okay, well, there's your answer. X is bonds. Good thing you wrote this down. Y is stock shares. To maximize your profit, you should buy $20,000 worth of bonds and $10,000 worth of stock. And you will get a return of 2.6 thousand or 2,600. So we've answered everything they wanted to know. And that's what I expect you to do on these problems. Okay?
What's all this jabber-wobbing when there's work to be done?
Oh, you got to get home and do that homework. Okay, let's get to it.